Hi, welcome to 8.4 Systems of Linear Equations in Two Variables, the application section. I've been having some issues with uploading this video, and the reality of it is if I set these up and do the problems, the video gets quite long. So what I'm going to do is I'm going to do this in two parts, where in the first part I'm going to set up all the story problems, and then many of you from the actual setup could solve them yourself, but in the second part I'll solve them. The third part, I'll set up the ones on the second page, and then the fourth one, I'll solve those. So that's just going to be the general strategy for these to make the videos a little bit shorter. And I think after you have the setup, you can probably solve them yourselves, but we'll have those videos up here in a minute. So just looking at the first one, Jimmy's fleece sold 40 neck warmers. Solid color neck warmers sold for $9.90 each, and striped ones sold for $12.75 each. In all, $421.65 was taken in for neck warmers. How many of each type are sold? Now, when it asks how many of each type are sold, well, we have solid color and we have striped. So these are the ones we're talking about. And because it asks how many of each were sold, that's how we're going to define our variables. We're going to set x equals number of solid, and y equals number of stripe. Okay, so this is the number of solids sold, the number of stripes sold. So we go back and read, Jimmy's fleece sold 40 neck warmers. So the number of solid plus the number of striped is 40. From that we get x plus y equals 40. That is the equation we can derive from that. So what we have is neck warmers plus neck warmers equals total neck warmers. We're equating the neck warmers in this first equation. Now in the second equation, we're going to equate money. So each of these solid neck warmers is $9.90. So 9.9x. This right here represents the amount of money we're taking in from solid neck warmers. Plus. Now striped neck warmers are $12.75. So 12.75 y. This is representing how much money we're taking in from the striped ones. So the amount of money we get from the solid plus the amount we get from the striped is the total amount of money we have, which is $421.65. And this is the system of equations for that first one. Now, a lot of these are very similar in setup, so I want to talk about the similarities. As we move to this next one, Deep Thought granola is 25% nuts and dried fruit. Oat Dream granola is 10% nuts and dried fruit. How much Deep Thought granola and how much Oat Dream? So how much Deep Thought and how much Oat Dream granola should be mixed together to form a 20-pound batch that's 19% nuts? So it asks how much Deep Thought and how much Oat Dream. That's how we're going to define our variables. We can say x equals pounds of Deep Thought So that's the pounds of Deep Thought granola, where y is going to be the pounds of Oat Dream. Okay, so the number of pounds of Deep Thought plus the number of pounds of Oat Dream is going to be the total number of pounds. So since we have 20 pounds, we're going to get x plus y equals 20. And this is kind of analogous to in this problem before, where we had right here, we had our x plus y equals 40. We have the sum of the parts of the whole. Number of neck warmers plus number of neck warmers is total number of neck warmers. Down here we have, pounds of Deep Thought plus pounds of Oat Dream is total number of pounds. So that's what we're doing. Now we're going to equate the next ones via the protein. Now, Deep Thought is 25% protein, so 0.25x. This is the amount of protein we're getting from the amount of nuts and dried fruit we're getting from the Deep Thought. When we add this to 0.10y, this is the amount of nuts and dried fruit we're getting from the Oat Dream. Now notice, we have percentage times pounds plus percentage times pounds. This has to equal the total amount of protein. Now, the total amount of dried nuts and dried fruit. We have 19%, or we're looking for a 19% mix, so 0.19. And we want a total of 20 pounds, so 0.19 times 20. So once again, this first equation, pounds plus pounds equals pounds. The second one, nuts and dried fruit plus nuts and dried fruit equals total nuts and dried fruit. And it's consistent with the way we have this. We have percentage times pounds, total percentage times total pounds. So that's the setup for that one. So in this next one, I kept saying protein because I was thinking about this Next problem, which essentially is the same as the problem we had before. These are mixing problems. So here, soybean meal is 16% protein, cornmeal is 9% protein. So how many pounds of each? So once again, how many pounds of each? This is telling us how we're going to define the variables. So how many pounds of each should be mixed together to get 350-pound mixture? That's the total amount we want. That's 12% protein. So if we say S is soy, and it's pounds of soybean meal, and C is pounds of cornmeal, then the pounds of soybean meal plus the pounds of cornmeal is the total number of pounds, which is our 350, so consistent with the last two problems. And now we're going to equate the second equation using protein. Now, soybean meal is 16%, so 0.16 S. This is the amount of protein we're getting from the soybean meal, plus 0.09 C. This is the amount of protein we're getting from the cornmeal, equals the total amount of protein. Well, we want a 12% protein mix, and we want 350 pounds. That right there is the exact setup we're looking for, right? Okay? So hopefully these are making sense the way we set them up. The way we solve these, we could use substitution, we could use elimination, and in the next video you'll see me solving these, so not too bad. So the last one is about student loans, and we need to have an understanding of the way that interest works. Now, interest works kind of like this. Interest, and simple interest at that. Interest equals principal times rate times time. Now, principal is the amount of the actual loan, or the amount of money you're starting with, the amount of money you have in the bank, or something along those lines. That's what we're thinking about, the initial amount of money. The rate is the percentage, these annual percentage rates. And you can see right here we have one loan at 6%, simple interest, so that's the rate, and one at 9%. And then time is always time in years, because these are annual rates that were given. So when we read this question, Sarah's two student loans totaled $12,000. One of her loans was at 6%, simple interest, and the other was at 9%. After 1 year, so once again we have the number, our time variable, Sarah owed $855 in interest. What was the amount of each loan? So we don't know the amount of each loan. So let's say X equals loan 1, and Y equals loan 2. Okay, so the amount of the first loan, X, plus the amount of the second loan, Y, is the total amount she borrowed, which is our $12,000. Okay? Now we're going to equate the second one via interest. So the first loan was at 6%, so 0.6 times, so that's our rate, times the principal. Well, we borrowed X dollars, so times our principal, and then times our time, which is 1, because we have it in there for 1 year. So this is the amount of interest from her first loan. The amount of interest from her second loan, well, it's at 9%, so 0.06 for the 6%, sorry. So 9%, so 0.09. How much are we borrowing? We're borrowing Y dollars, times the time is 1. So this is the amount of interest from her second loan. So the amount of interest from her first loan plus the amount of interest from her second loan is the total amount of interest, which is $855. That right there is the setup for the third one. So that's what we got. I'm going to go ahead and load this video up, and then in the next one you'll see me solve these.